Okay, first thing I'm going to do is finish the lecture I gave to C block for the benefit of the E block people who have the fire drill. So if you're in C block and you don't want to hear this again, you can skip, but this is the E block. So in E block, we were just getting started talking about coterminal angles, and I think we sort of understood them. We got to that point, but what we didn't get to do is say more of a formulaic, how do you find a coterminal? You can take the angle plus 360, or you can take your angle minus 360 and get coterminal angles either way of that. You could also do more than 360. You could take the angle plus 720, because once you get to a coterminal, you can get to the next coterminal by going one more time around the circle. So let's make sure we have this kind of definition now, or a formula for how to find coterminals. Okay, so the next thing then is talking about radians. Okay, we want this, rather than degrees, you have to be very, very careful that we put a degree mark on that 360 like I had forgotten to do. It's very bad. So don't forget, because that just tells you you're measured in degrees when you use the degree mark. But the deal is we have an alternate method to measure angles, and that's called a radian measure. All right, and a radian has... Okay, so a radian measure has a definition where if I took a circle, and I had my sort of standard position here, and I opened up an angle to the terminal side here, and I made those lengths finite. So those aren't rays anymore, they're segments. Okay, line segment now for the two sides of my angle. And I made them length R. So this is a length R, this is a length R. Okay, so kind of like the radius of a circle here. Then that is going to subtend an angle. So this, an arc length actually, sorry, that subtends an angle, but it also has this arc length that is the distance along the circle. So the length of the arc. Okay, so there's an arc length equals R as well if the angle is equal to 1 radian. Okay, so if you pick the angle just right, so that this radius here, the length of the terminal side, is the same length, I've tried to make it look like they're the same, that same length of the arc, then you have an angle that's equal to 1 radian. Okay, so just to give you an idea, that's 1 radian, so you could keep going around and get, you know, that would be 2 radians. Let's see, 3 radians, so I'm not quite there, am I? So that would be more like 1, that would have been more like 2, this would be more like 3 radians, and you keep going around 4. I think that's 5. Maybe that's 6. And this turns out to be 6.28 radians. All the way around 6.28 radian. So one circle is approximately, because it's been a rounded decimal, it could go on much longer for the decimal, 6.28 radians. Here's a good point to mention. A radian for a measure really has no units. Okay? So if you're looking at this, if theta is equal to, 16 degrees, or maybe another angle is equal to 16, these are two very different angles. This one is in degree measure, because it says degree. This one doesn't say anything at all. There's no unit written. That is assumed radian. Okay? So you do not need to write the word radian. You just have to not put a degree mark. So what happens when you forget to put a degree mark? Guess what? It's wrong. Okay? If you forget a degree mark where there is one degree mark supposed to be there, then you've just changed the angle by a lot, okay? And it's a wrong answer unless you put the degree mark where it is intended. If it's not there, I'm assuming you're telling me it's a radian. Alright, so we have these things called radians, and you get a little more than 6 of them around a full circle. let me do one more thing on the next page. Okay, so what I want to do is I want to mark some angles on this in the different ways we have of marking angles. Of course, we had degrees, 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Okay, if I were to put these in radians, okay, let's go red, then you have 0 radian. I'm going to have to get my calculator out here. In a decimal answer, I have radian is about 1.57 here. At 180, you really have 3.14. And then, of course, at 270, I would need to take 1.57 plus 3.14. I'm getting 4.71. And then over here, we already talked about 6.28. I can't get the 8 on there, but it's there. There it is. In a decimal approximation. But of course, we like to be more exact. And when you want to be more exact here, and what you'll see us do most of the time, is, of course, use pi. The value of pi is 3.14159, blah, 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 goes on forever and ever. And that's the exact measure of how to get all the way, well, pi is halfway around a circle, okay? Makes no sense because a pizza pie is a whole circle, but 1 pi is actually half a circle. So if I was to measure this in pi radians, radians in terms of pi, is how that would be. This would be, oops, 0. Start at 0, dummy. This, of course, then would be pi. This would be pi over 2. This one would be 3 pi over 2. Okay, so I have it labeled in terms of pi. So then, of course, we're going to just go back now and do some in-between angles. So this is something you really want to get good at. I'm going to give you a quiz on this. Not the next time we get together, but the time after. Halfway between 0 and 90 is 45 degrees. Halfway between 90 and 180, let's see, I'd just add 45 to 90 and get 135 degrees. Halfway between 180 and 270 would be 225 degrees. Don't forget that degree mark. Halfway between 270 and 360, because I could also call this 360 degrees, and I could also call this one 2 pi. Okay, so remember, 2 pi is equal to 1 full circle. But I was trying to get this halfway in between things, so where was I? Between 270 and 360 would be 315? Yeah, 315. Okay, so I have those angles. Now let's put those in terms of pi. I really did that once with the degree, with radian measure in decimal, but for the most part we're going to stick in terms of pi. So it's between 0 and pi over 2 would be pi over 4. Okay? Between pi over 2 and pi is 3 pi over 4. Now, if you're getting a little, confused by the fractions, take your time and try making an average. Or you can say, well, between here and here is a difference the same as this difference, so it's a pi over 4 more than that. So I could have said take pi over 2 plus a pi over 4 to get my 3 pi over 4. The other thing you can do is you can count in pi's over 4. So here's 1 pi over 4, here's 2 pi's over 4, here's 3 pi's over 4. And of course this next one would be 4 pi's over 4, which would be just the 1 pi. So we had that here. And then from 4 pi over 4, I could go one more and get to 5 pi over 4. One more would be 6 pi over 4, which reduces to our 3 pi over 2. So one more than 6 pi's over 4 is 7 pi over 4. And one more would be 8 pi over 4, which reduces to just our 2 pi right here. So you should be able to mark all those values of the angles using radians in terms of pi. The last thing I want to do is keep making these smaller increments. So let's try this. If I want to, instead of dividing between 0 and 90, I divide it in half to get 45. This time I want to take 0 and 90 and divide it into 3 parts. So they would be 30, 60, 90. So here I've got this angle right here would be 30 degrees. This angle right here, that's not quite right, is it? So maybe more like here would be 60 degrees. I could keep going. I've got another 30 would be 120 degrees. Another 30 would be 150 degrees. Another 30 would be the 180. Another 30 would be 210 degrees. Another 30. You see, this is getting a little repetitive. It's an exercise. It's good to do. 240, then makes 270. Another 10 makes 300. And another 30 makes 330. And finally, you'd be at 360 after that. Okay? But now, could you put those 30, 60, 90s, 120s using pi? Okay? So it's getting a little crowded, but let's see if we can find another color. Pink, dark pink, lavender. Oh, okay. So instead of 30, you know, it was a third of pi over 2. So that makes it a pi over 6. Okay? And then I have 2 pi's over 6, which is really pi over 3. And then I'd have 3 pi's, I'm sorry, I had 1 pi over 6, I had 2 pi's over 6, then I'd be 3 pi's over 6, which would be the same as pi over 2. So where was I? 3 pi over 6. And then I need a 4 pi over 6, which reduces to 2 pi over 3. And then I'd have a 5 pi over 6. And then a 6 pi over 6, which means I'm back to pi. Then I'd have a 7 pi over 6. And then I'd have an 8 pi over 6, which reduces to 4 pi over 3. And then I'd have a 9 pi over 3, which 9 pi over 6, which reduces to 3 pi over 2. And then I'd have a 10 pi over 6, reducing to 5 pi over 3. So that was what, 10 pi over 6, so I need an 11 pi over 6 for the next one. And finally, I'd be at 12 pi over 6, which would of course reduce to my 2 pi. Alright, I have labeled this terrible beast with every angle measure in both radians and degrees. Okay, so this is a monster, but I expect you to be able to do that. Okay, so that will be a forthcoming quiz in your near future. Okay, so how do we actually say we were given degrees and we'd rather have it be expressed as a radian, or if we were given a radian, how would we describe that in a degree form? So you can go back and forth, it's not a big deal. You want to look at one circle. One circle, when you're talking about in degrees, is 360. One circle, when you're talking about radians, is 2 pi radians. Okay? So those are equivalent. So those are what we call unit multiplier. Okay? So you could say 360 degrees over 2 pi is equal to 1, because they both equal a circle, or 2 pi over 360 is equal to 1. Now, the only thing I'm going to do, make sure you have a degree mark there. The only thing I'm going to do is reduce this then, because you can think about it that way, or you can reduce it and just do a half a circle. 180 over pi, or pi over 180. So we tend to use this because it's already in a nice reduced form. Okay, saves a little bit of effort. And all you're going to do is you're going to use either one of these, making the units come out right, to change. So for example, let's try one. What if I had 540 degrees and I want to express that in radian, okay? So what you do is you start with your angle, and you take it times either one of these, this one or this one, but you want the degrees to cancel, right? So I'm going to have to use this one so that my degrees is on the bottom, because I already have a degree on the top. So let me use pi over 180 degrees. And what you see happens is the degree marks cancel. Okay, and then it's just a matter of reducing my fraction. So I got 540 over 180 pi will be dimensionless. There's no dimensions left, so that's a radian. Let me cancel some of those out, and I believe I get 3 pi. So the answer is 3 pi is the same as 540 degrees. Let's try one more. Let's say I want to convert 5 pi over 3 to degrees. I'm going to start with the 5 pi over 3. And I'm going to take that times what I need in order to get to degrees in the answer. So I'm going to want degrees in the top. So I want 180 degrees on top over, that's the same thing as pi. So all I'm doing is taking a number and I'm multiplying it by 1. I'm allowed to do that. And see what happens. Cancel out my pi's. Let's see, let me reduce this as best I can. That makes it 60. When I take a 3 out of 180, so 5 times 60 is 300 degrees is equal to the 5 pi over 3. Okay? So, oops, yep, so there's my answer. Sorry, I meant to circle the other one. So 300 degrees is the same as 5 pi over 3. Be careful. The pi can sometimes be a little bit deceptive. What if I had said convert 2.7 to degrees? It's the same question, okay? So this time I have to convert 2.7 to a degree. So I'll start with a 2.7. I'll take it times 180 degrees over pi. Okay, now this time I got my degrees on the top like I wanted, but I'll probably use a value of pi so I can get a decimal answer. So all I'm going to do is I'm going to pull out my calculator and I'm going to say 2.7 times 180 divided by the value of pi, and you should use the value of pi on your calculator. Enter that, and I get 154.7. So that is the same, oops, I need a degree mark. 154.7 degrees is the same as 2.7 radians. All right. So if you don't have a pi in your answer, you probably want to, give one without as well. Okay, let's talk arc length. Like we had mentioned a little bit when we were deciding how to define what a radian measure of an angle was. We can do this more generally, and we can have a circle, okay? And in that circle we have a central angle. This is good old geometry stuff, right? So the central angle is from the center of the circle, haha, and we can talk about the radius, of course, of a circle. And you remember all radii are congruent, so these are both radii. So I have a radius here and a radius there. But this length that this angle subtends from here to here, okay, that length along the circle, so it's a piece of the circumference, is an arc length. It's the length of the arc, okay? And we call that in general S, okay? And of course we call radius as r, and you should remember S is equal to r theta. What a super simple equation or formula to follow for the length of an arc. But there's one very critical thing you have to remember, and that is theta must be in radians. Okay, so why do we care so much about this? And I'll tell you where you're going to see this most often is when we're doing wheels. Okay, seriously, when you're talking about a wheel that rolls along the ground, if you think about it, how far the wheel travels, okay, so how far the car travels that the wheel is attached to, will equal the length of the arc that the wheel turns. So if here's an arc, it starts here, and it goes from here to here, then this entire length right here is the arc length. This would be the theta now, taking this wheel on the road example. And this arc length would just literally fold down and give you the length that the car travels, S. Okay? So how far did the car travel based on how much of its rotation of the wheel was rotated. Okay? So that's where we like to use those in a word problem. Alright, so let's go ahead and see if we can do this word problem using arc length. What we've got here is a tire. And I'm going to go in non-standard position, okay? But this tire is going to rotate through 3/4 of a rotation. So I'm going to go from here to there. That's 3/4 of a rotation. A full rotation would be how much? Let's keep it in radians. So a full rotation would be 2 pi. So 3/4 of 2 pi is how much of a rotation? Well, let's do this. 3 pi over 2. Okay, so that's the central angle, theta. Okay, they told me the radius is 33 inches. So if I'm going to use my formula, S is equal to R theta, then this S, the length, S is going to be this length from here to there. Okay, that length. S is equal to R, I'm going to use 33. Theta, I'm going to use 3 pi over 2. Let's go ahead and get rid of that pi with the calculator. And I'm going to do 33 times 3 times pi and divide by 2. And get 155.5 inches. And that will be the length of how far it traveled along the road. Done. Alright, see you in class.